Hey everyone, let's dive right into this explainer and completely demystify telecom networking. We're going to break down exactly how internet connectivity actually works beneath the surface. Because, if you've ever wondered why your internet is totally down, even when all the little lights on your router are happily flashing green, well, you are definitely in the right place. We're going to build a crystal clear mental model of how data truly flows, using the exact same framework that professional technicians use every single day. Here is our roadmap for today. We're going to hit the golden rule of troubleshooting, explore the road versus the traffic, tackle a fun real-world scenario, define some fundamental network roles, and finally, tie the whole shebang together with the client-server model. All right, starting right off with Section 1, the golden rule. Basically, troubleshooting 101. So, one of the most common mistakes a beginner makes is stepping right into a massive trap. You walk onto a site, you see a cable plugged in with a happily flashing green LED, and you just instantly assume, hey, the hardware looks fine, so the service must be working, right? Well, as we're about to see, that green light is really only telling you half the story. It's a total myth. Because the absolute crucial point is this: to become a truly great technician, you have to master the difference between physical connectivity and IP connectivity. Those two layers are completely different beasts. Knowing where one ends and the other begins is literally what separates the novices from the pros. Which brings us perfectly into Section 2, the road versus the traffic. This is where we look at the physical versus the IP layers. Think about physical connectivity as the road. That's layer 1. It's the tangible hardware, the continuous physical path built between devices. Then contrast that with IP connectivity, which is the traffic at layer 3. This is the invisible software layer where devices actually understand each other and exchange digital data packets. It's exactly like the distinction between a physically paved highway and the invisible traffic laws that actually govern the cars driving on it. Verifying physical connectivity is usually pretty straightforward. You literally just use your eyes to check layer 1. You're making sure the copper Ethernet cables are clicked in securely, ensuring the fiber optic glass strands aren't broken, checking that Wi-Fi and radio waves are broadcasting, and yes, looking for that solid green link or LAN light on the hardware. If the road is paved and continuous, your physical connectivity is good to go. But here's the catch with the traffic. You absolutely cannot see layer 3 with the naked eye. There are no flashing lights for default gateways or IP addresses. So to verify that the cars are driving safely, you essentially need digital X-ray specs. You have to use software commands like ping or traceroute to confirm that these invisible traffic laws and routing settings are actually working. Let's move to Section 3 and actually put this into practice with a real-world scenario. Picture this. You're visiting a frustrated customer's site. You look at their fiber modem, and it has a bright, beautiful green link light. The customer's laptop is connected with a perfectly working Ethernet cable. But when they try to pull up a website, the screen just throws up a "this site cannot be reached" error. Before we reveal the answer, ask yourself, based on our road and traffic metaphor, what part of the network is actually broken here? Well, the situation is actually crystal clear once you break it down. The physical status is totally working. The road is perfectly paved. But your IP status? That has completely failed. You essentially have a beautiful empty highway, but there is a massive invisible wall preventing any cars from actually driving on it. And the specific reason behind this failure? The router is locked out. It simply failed to get an IP address configuration from the telecom provider. The massive takeaway here is that a green light only proves the physical cable is good and nothing more. You must always verify IP connectivity before promising a customer that their internet is fixed. All right, moving into Section 4. Now that we understand the road and the traffic, let's talk about the specific vehicles on that road, the fundamental network roles. To see how all these moving pieces fit together, we're going to do a rapid-fire breakdown of the 3 main actors you'll encounter literally every single day on the job: the host, the client, and the server. First up is the host. This is a fantastic, all-inclusive term. A really great rule of thumb to remember is, if it connects to the network and takes an IP address, boom, it's a host. Your laptop, your smartphone, a smart TV, a network printer, or a security camera, those are all hosts. Just keep in mind that simple, unmanaged hardware, like basic switches that just pass data and don't get an IP address, are not considered hosts. Next, we have the client. A client is a piece of hardware or software that actively requests services, data, or resources from another device on the network. Think of it exactly like a customer in a restaurant placing an order.
When you open up a mobile web browser on your phone to look at a web page, your phone is acting as the client, sending a request out across the telecom network saying, "Hey, please show me this data."
And finally, the server. The server is the absolute powerhouse waiting at the other end of the network to fulfill those incoming client requests. These are super powerful computers built to stay powered on 24/7. They literally serve data back to the clients. A web server stores websites. A video server streams movies to your Netflix app. And there are even special telecom servers, like DNS or DHCP servers, which act as the invisible managers handling all your background network configurations. Which brings us to our final section, Section 5, the client-server model. This is how all that data actually flows. This is basically the macroscopic view that governs all data networking. It operates on a super simple, looping three-step relationship. Step 1, the client asks for data. Step 2, the telecom network carries that request. And step 3, the server provides the data back. It's just a continuous, looping conversation happening millions of times a second. So why is this so absolutely crucial to grasp? Because by understanding this exact model, you can instantly isolate bottlenecks, instead of just wildly guessing. When a customer complains about slow internet, you just ask, is the client device infected with a bug? Is the telecom network physically dropping packets through a broken pipe? Or is the destination server just overloaded and smoking? Knowing these three distinct parts helps you pinpoint the exact point of failure every time. So, I'll leave you with this final thought. The very next time you walk onto a site and see a happily flashing green link light, you have a choice to make. Are you going to blindly trust the road, or are you going to use your tools to actually verify the traffic? Keep that in mind, and thanks for joining us for this explainer.